Hi students, welcome to my lectures on thermodynamics. As we are discussing about the heat, let us more discuss about the enthalpy. In the last class, I have given you a small indication what exactly the enthalpy is. Enthalpy is the energy associated with the molecule. Okay, if we go deeper into the concept, we have to find out the enthalpy in a different situations. Right, there are number of situations arises. So let us briefly discuss about those situations and what are the different terms involved in estimating the enthalpy. Even though when you're trying to find out the energy content, there are many applications of uses of this energy content in heatings, coolings, reactions. Okay, in every different situation you need to find out this energy content associated. The more technical term is enthalpy, as we discussed in the last class. And if I categorize the applications of enthalpy in different situations, I have categorized into 4. One is estimate what is the specific heat capacity. And I told you that there are two specific heat capacities. One is specific heat capacity at constant pressure. Second is specific heat capacity at the constant volume. In majority of the situations, like in mechanical engineering or chemical engineering, CP, that is specific heat capacity at constant pressure, is more important. Because generally, equipment operates at constant temperature and pressure conditions. Mainly the pressure. We maintain the constant in an equipment like distillation columns, evaporations, and if I talk about the different things, we operate at constant temperature and pressure conditions. Okay, in such cases, the specific heat capacity at constant pressure takes a more advantage and a value compared to the specific heat capacity at the constant volume. So the first thing in the enthalpy, we all should learn about CPIG. IG means normally we consider generally all this enthalpy and work estimations normally comes from the ideal gases or ideal liquids kind of. So that is why CPIG means we are estimating the specific heat capacity of the components which are close to the ideal, example ideal gas. Okay, that is why CPIG is required. IG represents ideal gas. So this CP values are available at the back of the textbook. That means a chemical engineering book by Smith and Vanis. If you refer to the how to estimate the heat capacity is given. That means if you know the constants like specific heat capacity const A, B, C, D. These are the 4 constants associated with every gas. If you know the A, B, C, D of any particular gas, you can able to estimate what is the CP, and liquid also available. So this is how we can estimate the CP. So the second thing, because you need the idea of CP to estimate the enthalpy, energy contents. The first situation we are going to analyze is heating or cooling purposes. Like example, in any situation, if you have to provide the heat or remove the heat, you need to use this formula. Change in enthalpy is nothing but integral temperature T1 to T2 Cp Ig dt. T1 is my initial temperature, T2 is my final temperature. So you can estimate the heating or cooling requirements using this formula. But in the textbook, you will often see the term CPIG by R instead of a CP. It's simple. The equation is the same, divide and multiply with R. So because R is a universal gas constant, you can take 1 R to the inside of the integral. Normally in the textbooks, CP is not given, CPIG by R is given. What is the advantage of CPIG by R? CP and R have the same units. They will cancel out. Okay, that there is an advantage with the non-dimensional term. So CPIG by R is given. Once you know the CPIG, integral of CpIg can estimate the value of the enthalpy in heating or cooling systems. In thermodynamics by Smith and Vaness, this integral term has a special name. There are two names associated. One is ICPH and second is MCPH. That means for you to calculate the change in enthalpy, you have to evaluate this entire term. This entire term has a specific names. One of the names is ICPH, the second is MCPH. ICPH means integral of Cp to calculate the enthalpy. ICPH MCPH means mean heat capacity to calculate the enthalpy. That means either you can know this term or this term to evaluate this integral to calculate the change in enthalpy. Okay, this is for the heating and cooling systems. There are another situations that comes for enthalpy of reaction, because in a system, if the reaction is happening, you have to count how much amount of enthalpy is produced or how much amount of enthalpy is required for that reaction. You have to estimate the enthalpy of reaction. So in this enthalpy of reaction, I have categorized into number of things. One is, for you to know the enthalpy of reaction, the first term is standard enthalpy of reaction or standard state of reaction. Both are same. So delta H suffix T and subscript T and superscript is O is indicated. That means the standard state of reaction is represented by delta HT and the kind of degree. So this degree stands for whatever you have estimated the standard state of enthalpy, it is at 1 bar. Okay, in general, everywhere the standard enthalpy is represented at 1 bar. Temperature could be anything. It could be room temperature, it could be higher temperature, any temperature. So generally, if you see any enthalpy of the reaction, it is represented by standard state of reaction. That means the pressure they have considered is 1 bar. Because even though the things happens at higher pressure, enthalpy is mainly function of temperature and least function of pressure. So it doesn't matter what the pressure you are dealing with. Important thing is, in a system, if the reaction is happening, temperature is more important rather than the pressure for the ideal gas situations. So that is why always the standard enthalpy, this degree representing, that means you are evaluating at 1 bar pressure. The first thing we will do, in order to estimate what is the standard state of the reaction is happening, an enthalpy is required. How you can able to find out this enthalpy? There are number of methods are there. One such a method is straight away conduct a reaction, see how much amount of enthalpy is produced or how much of enthalpy is required for that reaction. That is nothing but enthalpy of reaction. That means directly you can estimate by conducting the reaction. Second way. Why the second way is more important? Because in the world, there are number of reactions are there. That means I have to, in order to find out the enthalpy, I have to conduct each and every reaction. It could be millions, it could be trillions. There are number of reactions are there. For every reaction, every standard enthalpy, I have to conduct the reaction. I have to find out what is the enthalpy for the reaction. So which is very difficult. So the scientists come up with the new meaning, okay, new way of finding the enthalpy. That means to find out the standard enthalpy, you don't need to conduct a reaction. There is another way is, if you know enthalpy of formations, you can able to conduct, without conducting a reaction, if you know the enthalpy of the formation of every species involved in the reaction, then you can estimate what is the standard state of reaction. Second way, enthalpy of combustion. That means if you know, example, A plus B gives rise to C plus D. If you know how A is getting reacted with oxygen, B is getting reacted with oxygen, C is getting reacted with oxygen, D is getting reacted with oxygen, and that means a combustion. Okay. If you know combustion data of A, B, C, D separately, still you can able to find out this enthalpy of the reaction. That means to find out this, there are number of methods are there. One method is straight away conduct the reaction and find out the enthalpy. Second is if you know the formation of A, B, C, D, you can able to find out the standard state enthalpy. And third, enthalpy of combustion. That means if you know the combustion data, then you can able to find out the standard state of the reaction. These are the three methods we will discuss in very simple way. And in this enthalpy of the reaction category, the last thing that comes in is effect of temperature on enthalpy. As what we have defined here, delta H T degree means enthalpy of the reaction at temperature T at pressure 1 bar. That means if I conduct a reaction at 25 degrees centigrade, I know the enthalpy of the reaction at that temperature. What is going to happen if I conduct the same reaction at higher temperature? That means how my enthalpy of the reaction is changing from one temperature to another temperature. That means what is the dependency? So the last thing we are going to find out is how my temperature is affecting the standard state of reaction. Standard enthalpy of the reaction, both are same. Once you know these two, that means you know in heating or cooling situations you have to apply this. When along with the heating and cooling, if the reaction is happening, you have to find out the standard state enthalpy. That example, in a system, heating and cooling is also happening. Simultaneously reaction is also happening. That means we have to combine these two to find out the enthalpy changes in heating and cooling systems as well as plus reaction. That means you are going to combine these two terms. And the final thing that comes in adiabatic flame temperature. That means there is a box, I am conducting some reaction. That box is isolated. That means I have kept insulation over the box. I know what is my initial temperature, T0. What is the maximum temperature that is going to reach? That is nothing but T. This is nothing but adiabatic flame temperature. That means delta H, you know, from the in general second law, change in enthalpy. That means before and after the reaction, what is the enthalpy change? Q plus W. In adiabatic systems, no heat is going in, no work can enter. That is called the adiabatic systems. In such a systems, if I conduct a reaction in this box, what is the final temperature, maximum temperature? Because I am closing everything, right? No heat is coming out. Whatever the reaction happens, it will increase the energy of these products in this reaction. So in such cases, what is the maximum temperature attained after the reaction? When I close everything, that means I conduct the reaction in the adiabatic situations. So that is how finally we are going to estimate what is the final temperature T, because it is very important. That means, example, we should know that in an industry a certain reaction is happening. Suddenly, example, the power shortage happens, everything is, the cooling system failed. In such cases, if the reaction is happening continuously in that particular reactor, what is the maximum temperature reactor can go? You will have an idea. Okay, based on that you can design that particular materials of constructions and every other design aspects. So that is important, that to find out what is the adiabatic flame temperature. That means if I close everything, what is the maximum temperature it can be attained? Okay, that is nothing but the adiabatic flame temperature. And many students have doubts in the class. Sometimes people come to me, sir, why the delta H is equal to 0? Why delta H is equal to 0? What is delta H? Final enthalpy minus initial enthalpy. That means before the reaction it is T0, after the reaction it is T. And why this enthalpy is 0? Because the temperature is changing. If the temperature is changing, why you are saying that enthalpy equal to 0, change in enthalpy because of the reaction is 0? Let me explain. The reactants are entering at T0, the products are coming at T. That means the enthalpy of the reactants at T0 will be equal to enthalpy of the products at T, because A plus B example gives rise to C plus D. This A plus B enthalpy, which is equal at T0, will be equal to C plus D enthalpy at T. Even though the temperature is different, the products are different. So enthalpy of the products are different, enthalpy of the reactants will be different. Because of that, delta H equal to 0, because I am closing everything. What happens? Temperature is rising. Temperature is rising means the product at T temperature, the enthalpy of the product at T temperature will be equal to the enthalpy of the reactants at T0 temperature. So if I minus it out, it will be equal to 0. Okay, that's what we can able to gain from this delta H equal to 0. I hope. Let us go one by one to get you more clarity. Thank you very much. See you soon.